Hello, today we're going to talk about matrices. And matrix is an array of numbers enclosed by brackets. So it's a way to organize numbers. So for example, here's matrix A. How is it organized? And it has 2 rows of 3 columns. So 2 rows and 1, 2, 3 columns. So whenever we talk about dimensions of a matrix, we usually put the rows first and the columns second. So for example here, what is the value of matrix address 2, 1? A matrix address comes in the following way. The first number represents the row, second number represents the column. So if I'm asking for the matrix address 2, 1, I'm going to go to row 2, column 1, so the answer is 5. If here I say, what is the value of the matrix address 1, 3? So looking for row number 1, column 3. So row number 1, column 3 would be number 4. And the value 6 appears in what address? So value 6 is right here, is on the second row, second column. So address 2, 2. So let's look at some examples that we have over here. Suppose I have this problem number 1, consider matrix B below, and here I have a matrix, and it's asking what is the dimensions of the matrix B. Well, matrix B has 1, 2, 3 rows, so 3, and 1, 2, 3, 4 columns, 3 by 4. Alright, and what is the value of matrix B 2, 1? So a row 2, column 1 would be number 1. The value 11 appears in what address? Well, value 11 appears right here, which would be row 1, 2, 3. So it would be B, row 3, column 2. How about the value 5? Value 5 appears in B, row 1, row 1, column 3. Also we have another number 5, which would be row 2, column 2. Now number 0, we have various places. So one of them would be row 1, column 4, row 2, column 3, and row 2, column 4. So 1, 4, 2, 3, 2, 4. So let's look at another matrix. Remember, you can stop the video at any time to see the problems closer, or go back to anything area that you don't understand. So in this problem here, what are the dimensions of matrix M? It would be 3 rows and 1, 2, 3, 4, 5 columns. What is the address of M21? So row 2, column 1. Row 2, column 1 would be -1. What is the value in row 3, column 4? Row 3, column 1, 2, 3, 4 be -5. The value 7 appears in what address? Value 7 appears in address row 3, column 5. And the value 8 appears in row 1, column 4. So there you go. Okay. Alright, let's go on to the next part of our lesson. Second part of the lesson is adding, subtracting matrix. There's a special rule that you need to remember. The rule is, in order to add or subtract matrix, they must have the same dimensions. So here an example. Okay, I have different matrix A, B, C, D, and here they are. And I'm going to be asked to add or subtract them. So let's say I do matrix A. So first thing I do, I copy the matrix. So 4, -3, 2, -2, 10, 6, and I'm adding to matrix C. Okay, 3, 0, negative 5, 2, negative 9, 14. And basically, first thing I need to check if they have the same dimensions. So here I notice I have a 3 by 2, and this is a 3 by 2 matrix. So yes, I can add them, because according to the rule, let me focus a little bit more here. If they have the same dimensions, I can add them. And basically just adding them. So 4 and 3 gives you a 7. Negative 2 and 2 gives you 0. Negative 3 plus 0 is negative 3. 10, positive negative becomes a negative, so 10 minus 9 is 1. 2 and negative 5 is negative 3. And 6 plus 14 is 20. So this is our answer for our adding these two matrices. Alright, let's continue forward. Say I do matrix C, so let's copy it down. This would be 3, 0, negative 5, 2, negative 9, 14, and then be minus matrix A, which is 4, negative 3, 2, negative 2, 10, and 6. Again, I want to check their dimensions, so there's 3 rows here and 2 columns, and this is a 3 by 2 also. So because of that, they have the same dimensions, I can combine them. So what I'm going to do is basically what I'm going to do, I'm going to bring that negative inside. So basically I'm going to copy the 2 matrix again. So it'd be 2, negative 9, 14. And if I bring the negative inside, on the outside, it stays a positive. So this would be a negative times a positive is a negative 4. Negative negative becomes a positive 3. Negative 2. Positive 2. Negative 10. Negative times a positive is a negative. Negative times a positive is a negative. Alright, that way I don't have to worry about the signs. Okay. So 3 minus 4 is negative 1. 2 plus 2 is 4. 0 plus 3 is 3. Negative 9, negative 10 equals negative 19. Negative 5, negative 2 equals negative 7. And 14 and negative 6 gives me 8. And that's my answer for my problem there. Okay. Now, let's try the next problem. Next problem has C and B, so let's write down the matrix first. 0, negative 5, 2, negative 9, 14, and we're going to add matrix B, which is 4, 3, negative 1, 2, negative 5, 8. Okay. First thing, write down the dimensions. So this is a 3 by 2, and this is a 3 by 2. And what we notice is, whoops, this is not a 3 by 2. I'm sorry. This is a 2 by 3. Okay, first thing we notice is that the dimensions are not the same. So guess what? This is not possible. Okay. Okay. So the idea is always check your dimensions first before you start adding and subtracting, because if they don't have the same dimensions, you cannot add or subtract them. Okay. All right. Why don't you copy these problems down and give them a try. Okay. Welcome back. If you have tried these problems, so let's see what you got. Okay. Let me fix a little bit the light here. Alright, that should be better. Okay, so first thing we're going to do is write the matrix W, which is 3, 1, negative 2, 0. Okay, and then we're going to try to add y, which is 1, negative 2, 4, and 3. Okay. Okay, so if you notice, this is a 2 by 2, and this is also 2 by 2. So that means it can be added. So 3 plus 1 is 4. 1 minus negative 2, 1 and negative 2 is negative 1. Negative 2 and 4 is positive 2. And 0 and 3 gives you a 3. So that's my answer. Okay, let's go on to letter B. And letter B, my matrix X is 4, 5, 7, 1, 2, negative 1, minus letter Z, which is 2, 1, negative 2, 0, and 3, 4. So this is a 2 by 3, and this is a 2 by 3. So first thing I'm going to do is bring the negative inside. So it'll be 4, 5. Basically, I'm just copying the first one. For the second one, I bring the negative inside, so I'll put a positive on the outside. And this will change the signs of each one of these. So this will be positive 2, negative 3, negative 1, 0, negative 4. Alright. Okay, now with them, let me fix a little bit the image here. There you go. Alright, now what we're going to do is combine them. So before negative 2 is 2, 5 minus 1 is 4, 7 and 2 would be 9, 1 and 0 would be 1, 2 and negative 3 is negative 1, negative 1 and negative 4 is negative 5. And that is our answer. Okay? And let's try the last one here. Last one is x plus y. So let's copy the matrix. So 4, 5, 7, 1, 2, negative 1, plus 1, negative 2, 4, and 3. And we notice that this is a 2 by 3, and this is a 2 by 2. And by definition, you cannot combine or add or subtract matrix that has different dimensions, so you just write not possible. And that's our answer. Okay? Alright, let's continue with our problems. Okay, we talk about adding, subtracting matrix. Now what we're going to do is we're going to talk about simplifying matrix. Okay? So here again, there's a 4 matrix, but now I'm going to have numbers in front of the matrix. So basically what I do, I put a 2 there, and I copy the matrix. Okay, and minus 3 times 4, 3, negative 1, 2, negative 5, 8. And the rules too applies that you need to check the matrix dimensions. So this is a 2 by 2, and this is a 2 by 3. And guess what? Not possible. They have to have the same dimensions. So to add and subtract, they have to have same dimensions. Okay? So let's try letter B. Letter B is going to be a 3 by 3, 0, 2, negative 9, minus 2 times A, which happens to be 4, negative 3, negative 2, 10. Alright. So here I have matrix C. Matrix A is a 2 by 2. This is a 2 by 2, so I'm okay. First thing I'm going to do, I'm bring the 2 inside. So basically this will be a 3, 0, 2, negative 9, plus bring the negative 2 inside. So negative 2 times 4 is negative 8. Negative 2 times negative 3 is positive 6. Negative 2 times negative 2 is positive 4. Negative 2 times 10 is negative 20. Once I bring that in, that means I just do like I've been doing this far. Just combine them. 3 minus 8 is negative 5. 2 plus 4 is 6. 0 and 6 is 6. Negative 9 and negative 20 is negative 29. And that's my answer. Okay? Alright, very well. So now we're going to continue on to the next two. Next one I have 2a. So I'm going to write 2 times a, which is 4, negative 3, negative 2, 10, and then write negative c, which is 3, 0, 2, negative 9. Okay, I notice this is a 2 by 2, this is a 2 by 2, so I'm okay to multiply these numbers, okay, and then combine them. Alright, so let's bring those numbers in. So I'm going to get 8, negative 6, negative 4, and 20. So basically I just did this times this, this times this, this times this, this times this to get these new numbers. I'm going to do the same thing here. This times this. Notice that I'm going to put the negative 3 inside, so this becomes a positive. And negative 3 times 3 is negative 9, 0, negative 6, positive 27. And now I'm going to combine like terms. 8 minus 9 is negative 1, negative 6, negative 10, and 47. Okay. Alright, our last example. Suppose I have D. So D is negative 6, 3, 8 plus 0.5, negative 6, 3, 8. And this is a 1 by 3. This is 1 by 3. So basically, I can combine these two because they have the same dimension. So first thing, let's multiply the 0.5 back inside. So copy the first matrix. 0.5 times negative 6. It's going to be, 0.5 is half of negative 6, so it will be negative 3. Half of 3 will be 1.5, and this would be a 4. Now, just combine them. Negative 6 and 3 gives you negative 9. 3 and 1.5 gives you 4.5. And 8 plus 4 gives you 12. So that's my... You don't have to write this positive here. So, negative 6, negative 6. 3 is negative 9. And sometimes you kind of make sure to put a space between the numbers because otherwise it looks like 38. So 3 plus 1.5 is 4.5. 8 and 4 is 12. Okay? So this concludes the lesson on the dimensions of the dimensions of a matrix, the address of a matrix, how to add and subtract matrix, and also simplify matrix. Basically multiplying a number times a matrix. Okay? So this concludes our lesson on a matrix. Thank you very much for your time. Have a great day.